Yes, good morning. Welcome to Marshall School of IT, powered by Jenga e-learning. And I want us to proceed with our EDS series. So we mentioned about the exploratory data analysis. So we mentioned that exploratory data analysis is mainly focused with generating data, getting data from the sources, from different sources, pre-processing the data, and then analyzing the data to generate some valuable insights. Okay, so we mentioned that for you to be very effective with EDA, we need some tools. So the first tool we need is Python programming, and specifically there is a library called NumPy. So we mentioned about NumPy as a numerical computation library that we use in EDA series. Okay, so specifically here we mentioned about the NumPy arrays, which are very crucial in analyzing and preprocessing numerical data. From there, we did some pandas tutorials, and we talked about pandas as a library that is useful in generating pandas series and pandas data frame. And we mentioned that pandas series and pandas data frame are the foundation of structured data in data science and data analysis. So from there, we now mentioned on how you can pre-process data using pandas and NumPy. So here specifically, we mentioned aspects like data cleaning, data wrangling, data transformation, and data aggregation using pandas and NumPy. Okay, so now we even went ahead further and did a case study scenario where we actually cleaned and pre-processed WHO life expectancy dataset that we mined from Kaggle.com. Okay, so in our today's series, I want us to proceed with EDA by doing a data analysis case study in such a way that now we want to analyze Amazon sales data. So to start us off, in terms of introduction, we're being told here that understanding sales data is crucial for e-commerce business because it helps in making informed decisions regarding the pricing, product demand, and even customer behavior. Therefore, in this lesson, we want to analyze Amazon sales data to uncover trends, patterns, and then actionable insights. So the objective of the analysis is to identify the following: the top selling products and categories, analyzing the sales trends over time. We also want to understand customer purchasing behavior, and we want to determine the impact of pricing on sales data. And finally, you also want to evaluate the regional sales performance. So the dataset that we are using have the following parameters. So if you want to get this data, I have uploaded the link for you here from Kaggle.com. From Kaggle.com, I have uploaded for you, from my Google Drive, sorry, I have uploaded the link for you here. So it's the Amazon sales data. So you can just click on the link. It's the second link here. Just click on the second link here, and you'll find the Amazon sales data. So we have several parameters, like the region where the product is being sold, the country, the item type, the sales channel, which we are talking about offline. So let's actually go through the columns that have been used in this dataset. So we have the following. So we have the order ID. This is the unique identifier of each purchase, the product name, the category of the product, the sales amount, the order date, the customer location, the quantity sold, and the discount applied. So with this data that we've mined from Kaggle, so if you want to have it, just open this Google Drive and then you can just download it from this link here. So with this data, Amazon wanted to generate some key insights for their analysis. So for example, the first insight they wanted to know is what is their sales trend over time, okay? So they want to analyze sales over various time frames, okay? For example, the daily sales, the monthly sales, the yearly sales. This is very, very important to identify the peak sales period. Okay, so they actually be analyzing the seasonal trends, when sales were spiking, and so on and so forth. Okay, they also wanted to know the best-selling products and categories, because some product categories consistently performs well, while others have sporadic spikes in demand. So a few best-selling items generated a significant percentage of revenue, and this will actually indicate a need to focus on high-performing products. So we also wanted to generate the customer purchasing behavior in such a way that they wanted to show a trend of customer loyalty in certain category. But okay, in the first analysis in this series, Amazon also wanted to understand their pricing and discount impact on their sales. And also we have an analysis where they wanted to know their regional sales performance. For example, they want to know which country has the best sales indicator over different countries that they have. So in this analysis that we are doing, we are actually seeing that applying, we want to see how this kind of analysis can be useful in different e-commerce stores across Africa. For example, we have Jumia.com, we have gg.co.ke, we have Kilimall here in Kenya, and so on and so forth. So how can they apply this kind of analysis to different e-commerce stores? So you're going to notice that you can use it to localize product selection depending on their demands. You can even perform seasonal and event-based promotion. You can perform mobile commerce optimization. You can perform regional pricing strategies. You can make targeted marketing campaigns, and you can also improve on logistics and delivery. So in conclusion, before we actually go to the actual code, is that with this kind of an analysis, different e-commerce stores can optimize their inventory management. They can enhance their marketing strategies. They actually improve their customer retention because they will be offering loyalty programs and incentive to encourage purchases. Okay, they are going to refine pricing strategies and expand on regional focus. So therefore, I'm saying that by leveraging these insights, businesses, especially on e-commerce platforms, can improve their sales performance and enhance customer satisfaction and maximize profitability. So now allow me to go through the code on how you can actually do this kind of analysis. So I've opened up a Google Colab notebook that has been hosted on this Panda series here. So just click on this link. Then it will open for you the analysis that was done on Amazon sales data. So from here, the first step here is to ensure that you have this data uploaded on your Colab sessions here. So that is the first thing you have to do. If you don't upload it here, then this will actually give you a challenge. Okay. So to have this one here, you first need to click on this link that I had shared. Click on this link. Then you download this data set. Ensure you've downloaded this data set from the link, like that one. So I've downloaded the data set. Now from here, you can actually click on your Google Colab sessions, and then you click on File Upload. Just click on File Upload, and then you locate your downloads, and then you pick your Amazon sales data, and then you open. So you have to ensure that you have the Amazon sales data uploaded on your Google Colab session, because we want to analyze this sales data to generate some very valuable key insights that can be used in their strategic decision making. So this is very important. If you have this one ready, just close the tab. And now step one, we just have to read the data from the source, and then we convert it into a pandas data frame. So we mentioned that a pandas data frame is a data that has been organized in tables in such a way that we have some records. Sometimes it's called the rows, and then we also have some columns. So in other words, a pandas data frame is a two-dimensional data where we have the rows, which represents the records for the sales that Amazon did, and then the different columns that represent the field. Okay, for example, we have the column to represent the region, another column to represent the country, and so on and so forth. So we actually have our pandas data frame here. Now from there, it is good we do some exploratory analysis so that we understand the data that we have in hand here. So if you run data.head, it will actually generate for you the first 5 records, okay? The first 5 records. So, sorry, after you've uploaded this data, you normally go to runtime and you run all the cells. You go to runtime, you go to runtime and then you run all the cells. Sorry for that one. Runtime and then you run all the cells. Now from here, if you run data.head, it will actually generate for you the first 5 records by default. So if you want more records, you can just add the number of records you want here. For example, if you pass 10, it will definitely give you the first 10 records for the sales that was done on this Amazon data. So they are here actually, the first 10 records. And remember we said that in pandas series and data frame, data is accessed through indexing. So the first record here is indexed. It's actually at index 0, the next record at index 1. So this first 10 records are ranging between index 0 all the way to index 9. Okay, so it's good to check how many columns are you dealing with here. So if you just run data.column, it will tell you that you have a column to do with the region, country, item type, the sales channel, the order priority, the order date, ship date, and so on and so forth. So these are the columns of interest that we want to analyze in our Amazon sales data. So another command that you can run is data.shape, which normally generates for you the number of rows and columns that we have. So for this sales record, we have a total of 100 records, 100 rows, and 14 columns. So we are actually analyzing a total of Amazon's 100 sales over a period of time. So if you also run data.size, it will give you the total number of data that we have. And now if you run data.info here, it will actually give you the number of records we have. So we're being told we have a total of 100 entries, which are ranging between index 0 all the way to index 99. And from there, we also have that this data is made of 14 columns here, and it is actually of a type that pandas data frame. Okay, so out of these columns, we also mentioned there are different data types. So for example, like we had mentioned in our previous series, we had said that any column that contains text data is called an object. For example, the region is an object, the country is an object, the item type is an object. And we mentioned that a column that contains discrete data, discrete number is a number that cannot be fractioned. It's a whole number, like the order ID is what we call the integer before. Okay, and also we have numerical data that have decimal points, like for example, the unit price, that is what we call a float, the unit cost, their total revenue, their total cost, and their total profits. So if you run data.info, basically you are returning the number of rows, the number of columns together with the different data type that you need. Also, we can also run data.describe to do some statistical data analysis for this data, where we are getting the total count for the record we have is 100, the mean for all the numerical columns we have, the standard deviation, the minimum values. For example, the minimum unit sold was 124. The maximum unit sold was 9,925. For example, the minimum unit price is 9.3 USD, and the maximum unit price is 668 USD. So this is actually giving you a quick summary about the data that you want to analyze. So as much as now you are proceeding with this kind of an analysis, it's good to check whether we have some inconsistencies. For example, if you have some empty records, so we say this, to check whether there is an empty record, we say we just take your data, and then we run if now, and then we generate the sum. So I'm being told that there is no any particular column with an empty record. So this data is already cleaned and pre-processed for analysis. But in case you had some empty record, remember in our previous session, we talked about how you can actually clean and remove the empty records from your data. So these are the different data types we have. So for example, the region is an object, the country is an object, the order ID it's an integer, order date is an object. So this one is actually clearly telling us that this data was having an issue because the order date should have been a date time of a column similar to the shipping date. So these two data types should have been date time so that we can now perform the time series analysis later. So to avoid this one, what we can do is that we can take our data and then call the as type function. We convert the ship date to date time data. Similarly, we convert the order date to date time data. Now, if you run again the data.d types, you are now getting that the order date is a date time data. The ship date is also a date time data. So this will be actually be useful, especially later when we'll be doing the time series analysis. Now, from there, they wanted to plot a figure, especially a heat map, so that we can visualize any null value present within our data set. And we saw that no null value were present. In the heat map, we didn't see any null value present within our data. So we could also perform the annotation. So in case we had a null value, then it could have generated a different figure other than 0 here. So now from there, we wanted also to convert the total cost as float 64 data here. Okay, so we take our total cost column, we convert it to the floating data type. I think that is what we've added here. And then I think this is also visualizing any empty records we have. So now if you visualize the first 3 columns within our data, we are actually getting that I hope you can see that the ship dates are now converted to date time data, similar to the order date. So this data is already well pre-processed and ready for analysis. So now let's start generating these insights. So using this data, I hope you can see my screen. Using this data, we had several questions we wanted to answer. So this is actually how you do an analysis in your data. You'll have to have some questions that you want to answer. So if you want to do this one in SQL, so what we call the queries. What are the insights that you want to generate from this data? So the first one here is which regions have the highest total sales revenue? Okay, that's a very important aspect. It will be very useful for strategic decision making, maybe offering discounts and so on and so forth. Another insight that we wanted to get is what is the average unit price and unit cost for each item? Okay, which country around the world is generating the highest total profit? Maybe you might want to, Amazon might want to open a store in that country because it's the country that is contributing to the highest profit in their sales. So they also wanted to know how does the sales channels affect the order priority distribution? What is the average order processing time, okay, between countries? Which item type has the highest and the lowest sell? so that we can promote our mostly in demand products, and also try to promote the lowest products that are actually contributing to lowest sales. So also we wanted to know, how does the order priority varies across different regions? Yeah. And also, what is the relationship, or what is the correlation between the price of an item and the total profit? Is it a scenario whereby if I reduce the profits, if I reduce the unit price, is it getting me profits? Or if I increase the price, is it getting me some profits or some losses? Is there any seasonal trend in time series or patterns within the sales data? And also, how does the number of units sold varies across different countries? So these are the kind of analysis that we wanted to do, and I wanted to start with them very, very fast. So the first question that Amazon wanted to know is that, which region have the highest total sales revenue? So to do this one, we are going to create a variable called highest total revenue. So this is a variable. This variable, we are going to take our data, we group by the region. So we want to get all the region. Then after getting all the region, that is what we call group by. And remember, we had mentioned that group by function is only applied to object data types like region. So after grouping by every region, now we wanted to get their total revenue. So we want to get an aggregate total revenue. Now from here, we want to, we take our data. So if I comment this piece of code here, we can now run this one. I think I should just, okay. Not printed, so this one will actually return for us all the regions with their total revenue. For example, Asia is contributing to this kind of a revenue. Australia and Oceania is contributing to this revenue. Central America and the Caribbean are contributing to this sales on Amazon. So Amazon might want to know, out of all these regions, so I hope you can see that regions are based on the continent. So like Sub-Saharan Africa, we have the North America, areas like the US and Canada, the Middle East and the North African regions, and so on and so forth. So which are the regions that contribute to the highest revenue in Amazon? So to do this one, we can just take this data and call the ID max function. So this ID max function will return for us a region that has the highest sales here. So if you run this one directly, you are being told that that region is Sub-Saharan Africa. So these are very good insights to Amazon, showing them that most of their sales are actually being done in Sub-Saharan Africa. So Amazon might also want to visualize this one, so that to confirm that indeed Sub-Saharan Africa contributes to the highest sales on Amazon. So to do this one, we'll first group the data by regions, and then we get their total revenue, okay? So then from there, we want to do upload. So we can start with SNS. We define the style of our visualization. Using the matplotlib, we can now define the fig size. So this is the x-axis, this is the y-axis. And then to do this one, we can actually use a line plot, okay? Where the data that you want to plot is this group data. We can actually define the style of our line, the width, we provide the markers, and so on and so forth. Then from there, we can provide the rotation, give it the title, the X label, the Y label, and then show the graph here. So after running this one, we are being told that this is the graph showing Amazon sales over different regions. I hope you can see that Asia, it's actually contributing to looks like 2.1. So in such a way that this one can be, actually means that you take 1, you multiply by 10 power 7. So this one looks like 10 million. So this looks like $20 million. Yeah, this looks like $20 million in Asia, Australia is contributing to $15 million. Caribbeans, they are contributing to $10 million. I hope you can see the conversion rate here, $10 million. Europe contributes to, looks like so like around $33 million. North Africa contributes to around close to $15 million. North America contributes to close to $5 million. And now Sub-Saharan Africa, which we've actually confirmed was the highest total revenue, contributes to close to $40 million. So if this is a very strategic insight that Amazon can use to invest more on Sub-Saharan Africa, because they are the highest, this is actually where they're generating their highest sales. So that is a very good insight indeed that can be presented to Amazon for more strategic decision making. Okay, so that is the first analysis that you can record and it can be presented well to Amazon. Yeah. So then from there, we can now move further. Now we're talking about what is the average unit price and the unit cost for each item. Okay, so if you run this one, we have different items that Amazon generates. So we have the baby food, their unit price. The unit price is, the average unit price is $255. The average unit cost is $159. Beverages, $47 here, and so on and so forth. So if you want to, okay, I think this one we don't need to do any visualization. You can see that clearly we are seeing that most of the clothes on average in Amazon, they are sold at around $109 at a unit price of $35. Cosmetics and so on and so forth. Now, a very important aspect is, out of all the total Amazon sales, which country has the total highest profit? This is a good one, actually, that Amazon might want to know. So we can create a company called Total Profit by Country. This should have been country, sorry. This should have been country, my company. Then we take, this should have been country, not company, should have been country. So we take the data, we group by the countries, we get their total revenue. So let me first comment this one so that we clearly understand. Okay, I think I also need to comment this one so that we clearly understand step by step on how we are getting these very important insights. So I will have to print this one right here. So if I run, so we're actually getting that now we are not grouping them by regions, but we are grouping them by countries. We are grouping them by countries. So each country and the total profit that is generating to Amazon, okay? So for example, Angola is generating around 69, 39, 11 total profit, and so on and so forth. Like here in Kenya, we are actually generating a total of 407, 630 in terms of revenue. So out of all these countries around the world that Amazon is operating, which country contributes to the highest sales? So like we just did with the region, we can also call the ID Max operation. And this one will actually give us the country that generates that one. And you can see that, let me print it here. So then we can actually print this variable. And we're being told that around the world, Djibouti is the country that contributes to the total highest profit in Amazon. So if to visualize this one, you can also do the same. We can actually group them by countries, generate a figure, design how we want our graph to look like, whereby on the x-axis, we pass the index, on the y-axis, we pass the data, okay? So if you run this one, I hope we can see that out of all the countries that Amazon operates in, I hope we can see that Djibouti has the highest profit, followed closely by Myanmar, then followed closely by, I think it's Pakistan, and then we have the Samoa Islands. Then going down, I can see there is a tie between Switzerland and Azerbaijan. So these are very important insights that Amazon can use, especially on their investment strategies they can have. Okay, so they might want to offer more incentives on Djibouti and so on and so forth. So that is a very nice insight. So out of all the countries in the world, Djibouti contributes to the highest profit. Out of all the regions in the world, Sub-Saharan Africa contributes to the highest total revenue in Amazon. So the fourth analysis is that how does the sales channel affect the order of distribution? So here we have two types of distribution. So we have the offline, where you can go and get a product from Amazon shop, or you can also order an item online. So out of these two sales channel, which one has the highest, affects the priority of distribution? So to do this one, we can group them by the sales channel, and then we count the number of the order priority here. We count the number of order priority here. So we have the high, so on and so forth. So to actually visualize this one, we're actually seeing that offline, this is actually the sales distribution plot. This is the sales channels order priority distribution for Amazon.com. So then moving further, what is the average processing time duration for each sales channel? So if you're buying an item either offline or online, which one takes how many times, what is the duration that that purchase takes? So to do this one, we can actually group the data by sales channel because it's an object, and then we take the mean processing time. So if you run this one, you're clearly seeing that if you buy an item offline in Amazon, on average, it takes 23 days to process, similar to online. So they are more or less close the same, but it looks like offline is cheaper with because it only takes 23 days and 4 hours to process that order. On the other hand, the online one takes 23 days and 12 hours to process that order. So if you want to visualize this one, you're clearly seeing here that this is the offline and this is the online. So there, more or less, there is a tie, because now we are counting the time from 0 all the way to 24 hours. So most of them take close to 1 day to process an order. So the sixth insight that we might want to get is which item has the highest and the lowest total sales. Okay, so we clearly are seeing here that we can group the item by the item type and then get their total revenue sum, their total revenue here, the aggregate revenue. So we can start with the highest revenue, which is the IDX max function. The lowest revenue is the IDX minimum function. So to run this one, we are being told that cosmetics have the highest total revenue in Amazon. Cosmetic products contribute to highest total revenue, while fruits contributes to the lowest revenue in Amazon. I think it could be true because you realize that fruits normally are perishable. So, and if you can look at the processing time, which is 23 days, so it's not very much effective to sell fruits on Amazon because they are very, very perishable. So to visualize this one, we can visualize all the products that we have in Amazon, starting from the baby food, the beverages, and then as we do that one, the highest one, we give it a green color. And then the highest one, we give it a green color. And then the lowest one, we give it a red color. So clearly you're being shown here that cosmetics contributes to close to 35 million in terms of revenue. 35 million in terms of revenue, the highest. On the other hand, fruits is actually the lowest sales. So maybe Amazon might want to know what is the reason why they are not selling much of the fruits. Probably it could be because of the perishability of the fruits they have and so on and so forth. So followed closely by cosmetics, which is the highest revenue contributor. We have household items, and we also have the office appliances. These are the highest, they generate the highest revenue in Amazon. So from there, the lowest ones are the beverages, the fruits, the meat, and the snacks. Because one thing you're noticing that these products are perishable, and processing for like 23 days is not that effective. Yeah, so now moving further from there, I just want to move very fast. So we go to the eighth analysis. What is the correlation between the unit price and the total profit? So to do this one, we can actually take the unit price on Amazon, we correlate it with the total profit. And therefore, we're being told that the unit price and the total profit are having a correlation of 0.5. So it's 50%, clearly showing us that if we increase the unit price, then definitely our total profit will increase by 50%. On the other hand, if we reduce the unit price, our total profit will reduce by 50%. So these are very good, positive correlation that we mentioned in our previous lesson. So if you want to understand more about correlation analysis, then I would highly advise you watch our previous tutorial on data preprocessing. So to visualize this one, we are being shown here that unit price and the total profit are having a correlation of a positive correlation of 0.5, which is actually 50%. So then now that's a good insight to show, so that as much as now they are working on the unit prices, it's good that they keep in mind about the revenue or the profit that they might get. Now, in the ninth analysis, they also wanted to see, are there any seasonal trends and patterns in their sales data? For example, if you have the months of January all the way to the months of December. So we actually listed them in a dictionary. Obviously, this is a dictionary in such a way that the month of January, we assign it month 1, February, the second month, March, the third month, and so on and so forth. So then now from there, we can actually say that our monthly sales is to group the order date by generating the date time, we get the month. So we get the month, and then we group them by the total revenue sum. Okay, total revenue sum. So let me first see this one. Good, we understand here. So let me print here. Let me first print the monthly sales. I think it's already there. So I hope you can see that. Month 1, which is January, we have a total revenue of this one, the second month, and so on and so forth. So if you mark this dictionary, we'll actually convert the numerical ordering from month 1 to actually the name. Like January, we are getting a total revenue of this one here. February. So what we have done here actually is that we've taken the sales index. So initially the indexing was started from 1 all the way up to 12. And then we've applied the dictionary here, so that now we replace 1 with January, 2 with February, and so on and so forth. So clearly here we are saying that these are the monthly sales in Amazon.com. So out of here, it's good to see, out of all these months, which months have their highest revenue. So this one can be visualized in a bar plot, and this is actually what we are getting. So clearly we are being told here that the month of February has the highest sales on Amazon. I don't know what could be the reason. Probably it's because we have Valentine's seasons on February. So being followed closely by that one is the month of November. And then from there, we go to the month of April, the month of July. So their lowest selling month is August and March. So these are very strategic insight so that they can use to offer promotion on the lowest selling months. Like August, they offer a lot of promotions or a lot of discounts so that they encourage a lot of buyers to buy on their lowest selling months. Okay, so these are very good insight. Moving further, the 10th analysis is that how does the number of units sold varies across different countries? So they wanted to know which country contributes to buys a lot of goods from Amazon. Okay, so to do this one, we can group the data by the country, and then we get the units sold aggregate, and then we reset the index to the units sold. So if you run this one here, I think I can comment this one. If you run this one here, we are being told here that we've actually grouped every country with the total number of units sold they have. Okay. So, for example, Albania, the total goods they've bought is 2269, Angola 4187, Australia 12,995. So to have this one here is to ensure that we are displaying all the rows here. So this option allows us to display all the rows, the maximum rows. So we display all the records. Okay. Yeah. So we display all the records of a total of 75 countries that we have. So for example, in Africa, like Kenya, we have a total of 6,407. Another country is Djibouti, 23. So out of all these countries, which country have the highest? So to visualize this one effectively, we could draw a bar plot where on the x-axis, we display the country. On the y-axis, we display the unit sold. So if you visualize this one very well, then you are being told that now here, in terms of the goods that are being bought on Amazon, there's a country here called Sao Tome and Principe. They have the highest goods sold from Amazon, goods bought from Amazon. Followed by that closely is indeed Djibouti, which was also the country with the highest revenue. Followed closely by that one is a country here called Mexico. Then from there we have the Gambia. So Gambia also one of the countries that are getting buying a lot from Amazon. Then we have the Myanmar and so on and so forth. So countries like Kazakhstan, Kuwait, Slovakia, and the UK, they actually have the lowest units sold on Amazon. So that is a very key insight to know the strategic decision that now Amazon can take from here. So other queries could be, which I would now give you time to go through, is now, how does the total sales varies across different countries? So this one we have already visualized here. You're going to also have, what is the distribution of the unit price for each item? So we're seeing that office supplies have the highest distribution, followed by the household and so on and so forth. So which sales channels have the highest average price? So we are being told here that offline have the highest average unit price. Okay. Another analysis we wanted to know, is there any outlier in the total cost of distribution? So remember, we had said that for you to get outlier, we needed to get the 25 percentile and the 75 percentile. From there, we get the difference between the upper bound and the lower bound. So IQR, which is the interquartile range, is the upper bound, we minus the lower bound here, and we get our interquartile range. So then now we can run this one to our column so that we see whether we could have some outliers. And indeed, we have 3 outliers. We have 3 outliers that we can visualize in a box plot here. Can visualize in a box plot. I don't know why they are not showing. I don't know why they are not showing. Yeah, then from there, other analysis could be how does the total profit vary across different item types, and so on and so forth. So for this analysis that we've done today, we have actually done Amazon sales analysis. We've generated very important insights. A good example is that Sub-Saharan Africa contributes the highest revenue. Djibouti is the country with the highest total profit on Amazon.com. And also a country like Sao Tome and Principe is a country that contributes to the highest goods sold. So those are very key insights that Amazon can use in the analysis to make their key strategic decision making. So thank you for joining us, and see you in our next analysis. Bye-bye.